All right, so today we're talking about building functions. We're talking about area models. Okay. This lesson from 231 is full of a bunch of different examples, types of problems. Today we're just dealing with the area models. Tomorrow you're going to be dealing with a little bit more. It's related to roller coasters. So we'll look at that tomorrow. So first off, remember that the area of a rectangle is length times width. And it doesn't matter which is length or which is width. You can identify this as length, that as width. It really doesn't matter. But regardless, if we're given values here, numbers, constants here, we can multiply them together. If, like in the warm-up, this is an expression, and that's an expression, or variables, we can multiply them together and get the area. It doesn't matter. It's really a representation of area. Whatever is here, we can multiply together, and that would be the area. So our goal for today is to find the area of a painting and any frame. So we're going to find the area of a painting and any frame. Okay. So for instance, if you were working in a museum and you had a small painting, you could decide to make a very tiny frame. You could decide to make a huge frame around it. Right? That'd be great. What we're basically going to figure out is a quadratic, a formula that allows us to find the area of any frame around the same painting. Okay, it's going to be helpful in a bunch of different areas. Anybody want to do graphic design or any kind of like arts that is really computer-based? Computer design, game design, right? So within that, everything is modeled around different key numbers. So like the golden ratio is a ratio between areas. So if you were really at the top of your game with that, you'd be able to use this idea in finding these different ratios between the size of the painting and the size of the frame, the size of within graphic arts, how you put the graphics on any kind of medium like this. So this has application in those areas. First off, I spent all morning working on my Mona Lisa here. So I have Mona Lisa. It's postcard. It's a postcard size. So we have 3 inches by 5 inches. So what's the area of the Mona Lisa? This one. 15 inches. 15 inches what? Squared. We use squared units because it's area. It's not 15 inches. That's just one length. It's squared, so it's 15 inches squared. 3 times 5. Okay. So if I have this Mona Lisa and I have a frame that's consistent around all the edges, meaning it's the same width around the whole thing. If I don't know the actual width of the frame, is everybody okay when there's an unknown? When there's an unknown, can I just call that this width of the frame here is X? This width of the frame that I don't know is X because it's the same all the way around. It's not perfect, but they're the same. So I'm going to call those, this width here is X, that width is X. Just talking about the frame. Okay. So what we're going to do is we're going to figure out what my overall area would be when I have a frame that has an unknown width. Okay. So let's take a peek up here. We have the Mona Lisa again. That's 3 by 5, right? We know that the width we're going to call X because it's the same. It's a consistent frame all the way around it. So now let's look at this. If I want to find, we'll call this the length. If I want to find this length, what things do I need to add together to find this entire length? Let's look what's involved. I need to add together an X. I need to add together a 5 inches because that's how tall, that's the length of the painting. And then I need to add in another X down here. So let's see what we get when we do that. X plus 5. What do we get there? What's X plus X? 2X. X times X is X squared. So we're going to go with 2X plus 5. Okay. So likewise, on the bottom here, so the reason why is because if I just know this entire length times the width, I could find the area of the frame and the painting. So I do know that this portion is 5 inches because that's how big the painting is, right? I don't know this length or the width of the frame, so I'm calling it X. So we have an X length here, an X length here. So the entire length is X plus X plus 5. And I simplify that to this, right? Same thing for that bottom edge. The bottom length, or sorry, the width of this painting is 3 inches. I know that the width of this painting is 3 inches. And I'm going to go ahead and label again, this width of the frame is X. This width of the frame is X, because I don't know what those are. So then when I add together all of that, I'm going to get X plus X, which is 2X, plus a 3 inches. And actually these are both in units of inches. Okay. Any questions on that? What's the hardest part about that? What do you think? No crux yet? We don't have anything. It's just easy. I think maybe the hardest part is possibly remembering that we're looking for this entire width, and when we're looking for, sorry, I'm going to call this length as I have been. This is the entire length. So we know the length of the painting, but it's this kind of conceptual idea that we don't know this width of, or excuse me, the length of the frame. So I need to add together the X, the 5, and the X. So we get the 2X plus 5. All right, I think we got that. So next, what you can do is, just like we did in the warm-up over here. In the warm-up, we had 2 expressions to find the area. We just multiply them together. Okay. So looking at this, we took one expression, and the other, we just multiplied them together. Bless you. This is where you'll want to use our favorite factoring trick, or actually our favorite way to evaluate two binomials by using FOIL. First, outer, inner, last. I get down to this list of terms here. I'm going to combine my 6x and 10x, and I have it down here now. This is my area formula for the Mona Lisa in any frame size. Okay. So if you knew that you had to use a certain amount of space in the museum, say if you had 100 square inches squared to deal with, you could say, well, I'm going to find what my values for X will need to be, what the width of this painting needs to be in order for the area of the painting in the frame to be 100 square inches. Okay. So that's how we're going to deal with that actually tomorrow a little bit more. But looking at that, basically now we have the full area we could find of the frame and the painting based on what my frame width is. Okay. So let's see what happens now. If the frame is 2 inches wide, what is the area of the painting and the frame combined? What's good about this, we have this equation that allows us to find the area for those two things when the frame is different widths. So in this case, what I'm going to do is, since I know that the width of the frame is 2 inches, I'm going to go ahead and do f of 2. I'm going to do the function of 2 for this equation. So I do f of 2 is equal to 4 times 2 squared, just pulling it right from this equation, plus 16 times 2 plus 15. So if I set it up this way, then I could figure out what the full area is with this size of a frame. So we get 16 plus 32 plus 15, and that's equal to 63 inches squared. Now, if you, in your next art show, instead of these 2-inch frames, you wanted to use a 5-inch frame, really big frame. Okay. What would I do to find the area if now I'm using a frame that is 5 inches wide? We can plug it right in because this equation is talking about the frame and the painting. So if I plugged in 5 instead of 2, instead of being 2 inches, now the frame's 5 inches, I'd work this out and I would get down to my area for 5-inch frame. Okay. So setting these up is going to help you kind of find a shortcut to changing the size of the frame using the equation. Okay. All right. So the last part of this section is what is the area? Let me see. What is the area of the frame alone? I want you to think about that one for a moment. Maybe talk with your neighbor. How would we find the area of the frame just by itself?
Oh yeah.
All right, let's bring them back together. One group, raise your hand. Give me your strategy. Anyone? Bueller? Well, you laughed at my joke, so Daniel, you get to give it.
Okay, so 63 minus 15 because you're subtracting the area from the actual portion out of it if you want to get the area of the side.
Take that painting out, you have what's left over in the frame. So I know this was 15 inches squared from us doing that work in the beginning. This is 63 inches squared, so I'm going to take that 63 minus 15. Oops. 84 inches squared. 48 inches squared for just the frame. This is just for the frame. Okay. All right, so that is the intro to this whole topic. There's some fancy things we can definitely do because looking at this, right? This is the equation for a parabola, right? Since this is the equation for the parabola, we are able to find the maximum and the minimum values for different given values. So if I knew what the area was, right? If I say it's 100 inches squared, I could then work that out within a parabola to see where the maximum is of that. So just remember, if I just gave you this equation in standard form of a parabola, you'd be able to find the vertex, the minimum or the maximum. We could do all that because it's relating back to what we studied for entire Unit 2. So everything we could do with the parabola, all the information we could figure out, can come from this quadratic right here. So is this facing up or facing down? Open up or down? Open up. Happy face, sad face? Happy because it's positive, right? So we know it opens up. Okay. So based on the shape of the quadratic, we can also pull out some information on maximizing the size or minimizing it. Okay. So we'll touch on that tomorrow. The last type of example we need to do is when the frame is not consistent. So has anybody seen these kind of frames where maybe the sides are wider than the top and the bottom? Like some specialty frames, sometimes you see them. Okay. So we're going to find the total area if the frame sides are twice as wide as the top and bottom of the frame. All right, so let's look at that one piece at a time. Which components are larger? Is it the sides or the top and bottom? Sides. How much larger are the sides than the top and bottom? 2 times as much, right? So because I don't know what these frame values are, what I'm going to do is say the top and bottom are going to be x. Right? If the sides, left and right, are twice as big, I'm going to call that 2x. Right? A lot of this is interpreting information. So what I always like to do is first identify the smallest side. So if the sides of the frame are twice as wide than the top and bottom of the frame, I'm going to say the top and bottom are the smaller side. And I usually call the top or the smallest side x. That helps me because then I can work larger from that. So if this is x, it's this left and right, the sides are twice as big, I call it 2x. I know that the entire painting is 8 inches wide, 10 inches in length. So let's go ahead and figure this out then. What is my expression for this width right here? What do we have? 2x plus 8 plus 2x.
That's 4x plus 8.
Right? 2x plus 8 plus 2x. And that is 4x plus 8. Okay. We're using the variables we assign, and then we are adding them all together, and we're going to multiply them together. All right, how about this one up here? We have, let's see, we have x plus a 10 plus an x. So altogether that's 2x plus 10. If I had to find the area of the frame and the painting here, I would just find the product of those two expressions. Right? We can do this pretty quick. 8x squared outer plus 40x inner plus 16x last plus 80. So altogether the area of this one is 8x squared plus 56x plus 80. Right. These are the hardest ones, and there's going to be, I'm going to do one more sample problem because I think it's relevant to what we have to do for our classwork. Let's look at, I'm going to erase over here. I'll just shift it. It's going to make people at home sick. Sorry. All right, let's take a look over here. One little bit more, because we are going to need to, do a couple word problems from just the basic scratch. Okay, so if I tell you that a rectangle has one side that's 5 less than twice, let's see, has let's call this length, has a length that's 5 less than twice the width. So these kind of problems you're going to see in the homework. But looking at this, don't try to read the whole thing and then just create a model for it. That's going to be a little tricky. Let's read one little part at a time. A rectangle, okay? Draw a rectangle. Has length that's 5 less than twice the width. Which is the smaller side, the length of the width? Width. So watch, I'm going to call this, I'm going to call that the width. Okay. Now let's look at this. Let's look at each part one at a time. So if this length right here, the first thing I want to look at is, well, it's twice the width. There's another part to it, but the first part is it's twice the width. If the width is W, how can I express twice the width? 2W. And then let's look closer. The rectangle has a length, which is this I'm looking at now. That's 5 less than twice the width. Here's twice the width. How do I express 5 less than that?
Minus 5.
Right? You got to look at one part at a time. I always assign a real basic variable to the smallest side because you're often going to be working up from that. And then the area we could do really quick. W times 2, W minus 5 inches squared. They give us in inches. All right? You're going to see a few on the classwork just like that. All right. Let's see. Under 20 minutes. All right, how about, let's see. We'll have left versus right side of the room. So we're going to split you just like this, Stephanie, right through here, right? Okay. All right, we're going to have competition. We're going to say subscribe on 3, right side and then left side. See who wins. All right, right side. Subscribe on 3. 1, 2, 3.
Subscribe.
Oh, nobody knows which is right side.
Which
The
one's
door
our
side,
right
entry
right?
side. That's
Oh,
my
the
right.
door right.
Yeah.
Okay, I think you're talking our right.
All right. Subscribe on 3. 1, 2, 3.
Subscribe! Okay, he did outdid me there.
All right, left side. 1, 2, 3. Subscribe.
Subscribe. Damn on the haters.